Upbeat space-themed music fades in, show dramatic footage of the sun's corona erupting, transitioning to animations of the Parker Solar Probe hurtling through space. Display title card. Parker Solar Probe S. Latest secret. Surviving the Sun. S. Fury. In 2025, your on-screen host appears confident against a starry backdrop. Welcome to Space Secrets Udu, where we uncover the mysteries of the cosmos. I'm your name, and today we're diving into one of NASA's boldest adventures, the Parker Solar Probe. Imagine a tiny spacecraft, no bigger than a car, racing toward our sun at 430,000 miles per hour, faster than any human-made object ever. In 2025, it's not just approaching, it's plunging into the sun's scorching corona, just 3.8 million miles from the surface. How does it survive temperatures hot enough to melt steel? What fresh data is it beaming back? And what's next for this solar daredevil? Stick around as we reveal the secrets, the tech, and the future plans. If you're as excited as I am, hit that like button and subscribe for more cosmic wonders. Let's launch. BRO. Timeline animation showing the probe's journey. Launch on August 12, 2018, via Delta IV Heavy rocket. Venus flybys tightening the orbit. Insert infographics. 7 Venus assists. 24 planned close approaches. The Parker Solar Probe isn't your average satellite. Launched by NASA in 2018 from Cape Canaveral, Florida. This $1.5 billion marvel is named after solar astrophysicist Eugene Parker, who in the 1950s theorized the existence of solar wind, streams of charged particles blasting from the sun at 1 million miles per hour. Eugene, the first living person to have a spacecraft named after him, passed away in 2022. But his legacy is alive in this probe. The mission's goal: to touch the sun specifically, to fly through the corona, the sun's outer atmosphere. Why? The corona is a puzzle. It's millions of degrees hotter than the sun's surface, defying physics as we know it. Parker aims to trace solar wind origins, study magnetic fields, and uncover how energetic particles accelerate to near-light speeds. These insights could revolutionize space weather forecasts, protecting satellites, astronauts, and even Earth's power grids from solar storms. To get there, Parker uses gravity assists from Venus 7 daring flybys that slingshot it closer to the sun. By late 2024, it reached its optimal elliptical orbit every 3 months. It dives perilously close, then swings far out to communicate with Earth. No other craft has come within 7 times this distance. It's like sending a mosquito into a blowtorch. Precise, perilous, and groundbreaking. High-energy visuals. Slow-motion animations of the probe entering the corona. With fiery plasma jets. Overlay real NASA footage from previous flybys. Timestamped to 2025 events. Show distance graphic. 3.8 million miles. About 8 times Earth's diameter. Fast forward to 2025. This year marks Parker's pinnacle of daring. Its prime mission peaks with 3 historic close approaches. First, on December 24, 2024. Yes, Christmas Eve, Parker screamed through at blistering speed, its beacon signaling survival by December 26. Detailed telemetry arrived January 1, 2025, confirming it gathered pristine data amid the chaos. Then, March 22, 2025, the 23rd encounter, where instruments captured the corona's wild magnetic switchbacks, sudden flips in the solar winds, magnetic field that heat the atmosphere. But the crown jewel. June 19, 2025, the 24th flyby. Parker equaled its speed record of 430,000 miles per hour, enduring a 3-day plunge from June 14 to do a plume pad. Out of contact with Earth, it operated autonomously, collecting observations from its 4 instrument suites: Fields for electric fields, ISIS for particles, SWEP for solar wind, and WHISPER for visible light imaging. All systems green upon check-in June 22 at Johns Hopkins Applied Physics Lab APL in Maryland, where the probe was built. These aren't just flybys, they're time machines into the sun's heart. Data shows switchbacks generate heat, explaining the corona's mystery blaze. Parker even snapped Venus' surface in visible light during assists. A bonus discovery. Technical breakdown. 3D animations of the heat shield deploying. Cross-section views showing carbon foam layers. Heat map visuals. Shield at 1600 to 1700 degrees Fahrenheit. Instruments at room temp. Include test footage of shield in plasma chambers. Now, the million-degree question. How does Parker not melt? The corona exceeds 1 million degrees Fahrenheit, with radiation that would vaporize most tech. Enter the hero. The Thermal Protection System, TPS-A, 8 foot wide, kurang 4,5 inch thick carbon composite shield, weighing just 160 pounds. Crafted at APL, it says a sandwich of two reinforced carbon-carbon panels sandwiching a lightweight carbon foam core, like a cosmic thermos. The sun-facing side, coated in white ceramic paint, reflects 99% of sunlight. Tested to 30 degrees Fahrenheit, 1650 degrees Celsius in ground simulations. It hit 1600 to 1700 degrees Fahrenheit during 2025 flybys below design limits, thanks to the corona's low-density Y. Space is a vacuum. Heat transfers slowly without air molecules. It's like touching a hot oven bearable versus boiling water scalding. Behind the tip, autonomous smarts keep it perfectly angled sunward. Water-cooled solar arrays power instruments at a cozy 85 degrees Fahrenheit. Antennas made of heat-resistant niobium alloys extend into the inferno for readings. No wonder the team calls it bulletproof. It's rewritten. Engineering rules for deep space survival. Data viz, graphs of magnetic fields, particle flows from 2025 telemetry, animations of solar wind streams, coronal mass ejections, side-by-side, pre-Parker versus post-Parker models. Parker's 2025 hauls are goldmines. From the June flyby, fields detected switchbacks, born deep in the corona turbulent eddies accelerating particles to half-light speed. SWEAP mapped solar wind's birth, revealing how it accelerates from subsonic to supersonic WISP, are imaged never-before-seen dust rings near the sun, confirming a dust-free zone theorized decades ago. These nuggets explain solar flares and coronal mass ejections. CME's eruptions, hurling plasma clouds at Earth, sparking auroras, or blackouts. Parker's data, combined with NASA's heliophysics fleet, like SOHO, predicts space weather better than ever. Bonus. During Venus flybys, it unveiled atmospheric secrets, aiding future missions. In 2025, the team snagged the Collier Trophy for greatest achievement in aeronautics, a nod to Parker's game-changing science. Forward-looking graphics, extended mission timeline to 2029 to 2030, show concepts for next-gen probes, Artemis ties, end with Sun-Earth connection animation. With the baseline mission wrapping June 2025, Parker's not retiring. It orbits the Sun, observing until a 2026 review. Extension talks pass. Complete the 11-year solar cycle at 9.86 solar radii, about 4.3 million miles, potentially to 2029 or beyond. More Flybys mean deeper corona dives, tracking cycle peaks for flare forecasts. Long term. Parker's paving for human exploration. Artemis lunar missions and Mars plans need solar storm shields. This data delivers. Imagine AI-enhanced predictions, saving satellites worth billions. When fuel runs dry, Parker incinerates, its shield orbiting eternally, a monument to curiosity. As Eugene Parker said, we're opening eyes on our star. 2025 proves it.